everyone. This is me, Mohammed Hassan Reza, DSC lead of DSC University of Kotlin. For those who doesn't know about DSC, it's the student community, university-based community where we learn peer-to-peer learning and learn new technologies and stuff which universities doesn't offer. So, in the meantime, we can start with our event. We have Zoltan with us. He is senior Kotlin developer at Magyar, Telekom, and he's from Budapest. So we can start. Hello, Zoltan.
Hi, everyone. So can I start?
Yeah, sure.
Okay. So, hey, everyone. Happy to be here. And today I'm going to talk to you about Kotlin. I will give you some basic presentation. I'm going to share my screen now. Okay. I think that you can see it now. So let's jump into the middle. So my name is Zoltan Domahidi. I'm a senior software developer. I have 10 years of experience in Java and 2 years in Kotlin. And at the moment I work for Magyar Telekom, where we use Kotlin for backend development. And later you can find me here or find the demo in my GitHub account. And today I will give you a brief introduction to Kotlin. We will learn some basic Kotlin syntax, some code, and we will have a short demo, a tiny application. So before we talk about Kotlin, we have to talk a little bit about Java. Probably most of you already know Java. It's a very popular, it's one of the most popular programming languages. Basically, it's an industry standard programming language, and it is very popular because it runs on a wide range of platforms. Mainly, it is used on server side, but it also works for front end and mobile development. It has a great performance. It has a very good ecosystem and community, so you can find tools, frameworks, and libraries for your need. And it has a fantastic virtual machine. So everything is just so good in the Java ecosystem. But the language has some pain points. It got some critics. One of the pain points are that the language itself is very old, and they promise backward compatibility from the beginning. And this means it gets harder and harder to introduce new features because they have to think twice what features do they want to add, because later it will be hard to remove, so the feature must be useful. And mainly because of this, the language evolves slowly. And another pain point is that the language itself is verbose. So you have to type a lot just to achieve the same result what you can achieve with a modern programming language. There were a couple of programming languages appearing which tried to give a better alternative for Java, but keeping the benefits of the Java ecosystem. So you might know about Groovy, Scala, and Clojure, for example. They are good, but they mostly have some build performance problems, and they have a steep learning curve, so they can be complex. And 10 years ago came Kotlin. It was created by JetBrains. Basically, they needed a programming language what is running on Java virtual machine, and they wanted to use Scala because it was so expressive, but they had issues with the build performance, so they started to create their own programming languages, and this was Kotlin. And basically, this means that you write Kotlin code and it will be compiled to Java bytecode. So you can run it on Java virtual machine. The Kotlin language is also multi-paradigm programming language, what means that it supports object-oriented programming and functional programming as well. And it's 100% interoperable with Java, so you can use your tools and libraries from Java. You can use your Java classes and code without any problems. It is mainly used for Android development, but it also works very well for server-side development and front-end development. And it has a native project, what means that the Kotlin code will be compiled to native bytecode. And because of this, the application will have a very tiny memory footprint, and it will boot very fast. So it has a lot of performance benefits. And it has a multi-platform project, what means that you can write single code and you can run the code on multiple platforms, like on Android, on iOS, or on a web page. And this means that you can drastically increase the code what you can reuse in your projects. So you don't have to write the same application multiple times. Kotlin also has a great ecosystem and community, so they also have many frameworks and libraries for whatever you want to use. But of course, you can also use the tools from the Java ecosystem. It has a very expressive syntax, so it's easier to write the same thing what you would like would write in Java. It makes easier to write a readable code, what is important, because most of the time we read code, and if you find a readable code, you will understand it much faster. So you can spot easier problems and bugs, and you can start contributing to the project faster. So basically, this lets you be more productive with the language. By design, the language gives you more chance to work to write safer code. The two main features are the null safety and immutability. So when you write a Java application, most of the problems comes from nullability, from nullable types. And in runtime, you can have a lot of null pointer exceptions if you're not using this with care. Another problem is concurrency issues, and most of the concurrency issues could be avoided by using immutable variables, what means that you cannot reassign a value to a variable once you assign it. Kotlin has coroutines, what are basically very lightweight threads. Just to compare it with Java threads, if you write an application what would start 100,000 threads on the JVM, it would crash with out-of-memory error. But you can run millions of Kotlin coroutines without any problems, so they are very lightweight. And this is also important because nowadays we write applications for millions of users. So basically, writing a multi-threaded application, which is highly concurrent, is not an option anymore. It's a must. And Kotlin is also powerful in writing domain-specific languages. These are basically a higher level of abstraction of a programming language, and it allows to non-developer people to easily understand some code and even to contribute it. So some popular examples for DSLs are CSS and Markdown. So you don't have to be a JavaScript developer, or you don't have to understand HTML just to write a simple web page or just work on styling. So this is a domain-specific. This is a domain-specific language when a functional programming code is simplified for other people who don't have this knowledge to write the code. Okay, so Kotlin became popular a couple of years ago, but the Java community has some problems with it. They were afraid to use Kotlin because they were thinking that Kotlin is just another hype and it will disappear, or it can disappear, and it could be a risk to introduce in production. But in 2019, Google and the Spring Framework announced their official support for Kotlin. Meanwhile, many universities started to use Kotlin in their research work because Kotlin allows you fast prototyping. And many big companies also started to use Kotlin in production. So this means that Kotlin is not just a hype anymore, but it's a major programming language. And in this SNCC JVM ecosystem report from 2020, you can find that now Kotlin is the second most popular programming language on the JVM ecosystem, of course after Java, but Java started to stagnate or lose popularity slowly. This is mainly because the language evolves slowly, and I just have to mention here that later we will see mainly Java 8 codes, and a couple of years ago Java started to use a new release cadence, so they release a new version every 6 months. They introduced this because they wanted to speed up the evolution of the language, to add faster new features, and now I think they are version 15 and 16 is coming, but the ecosystem is still stuck on Java 8. So 60% of the Java ecosystem, especially in the industry, they are still using Java 8. So you have to cope with Java 8, and this is mainly why I compared the Kotlin code with Java 8 code. Okay, and let's have some fun, and then let's learn some Kotlin code, and you will see that working in Kotlin is indeed fun, especially because declaring a function in Kotlin is by using the keyword fun. So in the next couple of slides, I will show you some codes. Here, the top will be the Kotlin code. At the bottom, I just wrote some Java equivalent, so probably you know Java and you can compare it. And in the middle, I will describe what I'm talking about, so later you can read it back. It will slowly fade in, so I try not to distract you from the top part, because that's the main thing what we're talking about. So this is how you write a hello world application in Kotlin. Basically, you need 3 lines. You can put it in any kind of Kotlin files. So Kotlin gives you more freedom regarding to file usage, package usage, and class uses, as Java would do. So if you see the comparison, you don't have to specify a class just to start working in Kotlin. And it also saves you from some code that a beginner might not know what is it for, like what is this static, or what is this system.out, or what are these arguments. So later you can learn about that, but if you just want to start to work in Kotlin, you can write these 3 lines. And basically this is simple. You just write fun, so you declare a function. This is the name of the function, and this is the main entry point of your application. Parentheses, curly braces, and print line and a string, and that's it. And you even don't have to say that this is a public function, because in Kotlin, by default, everything is public. Even semicolons are optional, so it's not a problem if you miss them. So you will see that Kotlin tries to help you to work faster, easier, and try to give you as less information what you need to know as much as it's possible. So if we move further, and we start to use variables, we can see that this is how you declare a variable in Kotlin. Basically, you use the keyword val, what means that I will declare an immutable variable. So once I assign the value to this variable, it cannot be changed later. You will get the compile time error. But you can also use mutable variables, and you just need to use the var keyword instead. Kotlin allows you to use mutable variables because it's interoperable with Java, and many times you need to use mutable variables and nullable types. So it gives you the chance, but by default it tries to give you immutability and null safety. You can see that we did not specify the type here. This is because Kotlin has type inference, what means that it will figure out what type do you use. So you specify, you give here a string, and it will know that this variable holds a string. So you cannot do operations like number-related operations on that once you assign the string. You can also specify the type if you wish, or would you like to be strict on types. In Kotlin, we give types at the end of the functions or variables. And by default, every type is non-nullable. So as you can see here in this example, if I try to assign a null value to this variable, I will get a compile time error. So this is how Kotlin tries to save you from a lot of problems. It shows you null-related problems as soon as possible, so you can act immediately. But of course, you can use nullable types, and if you would like to use it, you just simply have to put a question mark after the type. And starting from this, you can use null. Okay, and another interesting point here that we can put a variable just right into a string when we use $sign. So Kotlin has string interpolation, and it helps you a lot to work with strings. You don't have to concatenate strings, and it's still readable. And you can write complex expressions into strings, so you can access properties or call methods. Okay. So as I said, by default everything is public in Kotlin, but you can also use private functions or variables. Here we just extracted something into this function, this hello function, and we said that this is a private function. We defined the variable into a function argument. So we give the type, it is a string, and its return type is also a string, and we return here a string. In Kotlin, if you can write a function in a single expression, you can write this function shorter, like this. So you can void the return type. You don't have to type the return keyword, and you don't need the curly braces. Just simply put it there an equation mark. So by using this style, you can write very easy one-liners, so one-line functions, and this also can make your code much easier to read. Okay, here is a more complicated example. So we started to use more arguments in this function, and we basically will rewrite this function, and the name will be repeated multiple times. As I said, you can just put expressions into strings, so the string templating will resolve this. And just a short comparison that here I used Java 11 code, so Java 11 already has this repeat, but older Java versions does not have this, so you have to write here a loop and concatenate strings, so it would be more verbose to write the same functions. But Kotlin gives you a lot of handy functions from the very first version. Okay, so you can see here that we give some values in the function arguments. This might look strange, but this is very helpful. So these are basically default values for these variables, and that means that if you do not specify the value when you call the function, it will use this default value. So basically, when we call the hello function with arguments Kotlin and 2, it will print hello Kotlin Kotlin. So the name two times, yes. But down here, if we miss the second argument, it will get the default value. So it will print hello Kotlin Kotlin Kotlin, so 3 times. And if you skip the first one as well, so you don't give any arguments, both will get the default value, so it will give you hello word. And you can also call the functions by referencing the arguments by their names. So you can use the named arguments. And for the first site, it makes more, the code a bit more verbose, but it has a lot of benefits. First, it makes your code less fragile for refactorings. Second, you can always see what is the argument, what you're calling. And this is important when you have a function with a lot of arguments having the same type. So let's say we would have here 6 or 7 or maybe 8 arguments, and all of them are strings. It might be hard to know which argument stands for what, but this way you can always see it. This also allows you to change the order of them. So if for some reason it's more easier to you to change the orders, then you can. It's very flexible, and this also allows you to, if the first argument has a default value, you can skip it. And in Java, you cannot do this. If you would like to do something like this, you have to use method overloading, what means you have a lot of hello functions with different signatures, and all of them we call one hello function. But in Kotlin, you can use it with the single function, so it is very flexible. Okay, and one more thing to note here, that we use here an int. It's basically an object, and this is because in Kotlin we have only objects. When Kotlin compiles to Java bytecode, it will translate it to a primitive or an object, but you don't have to care about it. So it tries to optimize this work for you. So Kotlin has expression. It has conditions as well, like Java, and the syntax is pretty much the same as in Java. So you can write the same if conditions. So you write if a condition, whatever is to Boolean, and there is an execution block, or else, and you can write a new condition. But in Kotlin, conditions are expressions, what means that they have a return type. And in every execution block, the last statement has a return, an implicit return type. So this means, in this example, if the number is less than 0, we will return 1. Else, if it is 0, we will return 0. Else, we will return 1. And because it has a return type, we can assign it to a variable. This is a nice feature because it gives you more power to use immutable variables. So if you would like to write the same function in Java, you have to use a mutable variable. So you will assign the value in each execution block. But because you are using a mutable variable, you you can have concurrency issues if you're not careful with this. But if you can assign it directly to an immutable variable, you can avoid these problems. And of course, when you would like to write complex conditions with multiple branches in Java, you would use a switch. In Kotlin, we use when, what is pretty similar to switch, but it's more powerful. It's much smarter. So we use this when keyword. You give a variable, and just like in switch, you have a lot of conditional branches. Here are some conditions, and if any of the conditions is fulfilled, an expression will be evaluated. And when is also expression, so it also has a return value. The last statement is an implicit return, and it allows you to do much more than you would do with switch in Java. In Java, with switch, you can use mainly primitives, enums, and strings. But in Kotlin, you can use custom objects, and you have more freedom here. You can see that we can use in the condition single value, multiple values. We can use different types. We can check if the variable is a given type, or if a value is within a range, and we will talk a little bit later about the ranges. And if nothing, if none of the conditions were fulfilled, then of course we have an else branch, what is the default execution block. And one small note here that we use this any. Basically, this is the object equivalent in Java. So any is the type that sits in the top of the type hierarchy, and every type is also an any type. Okay, collections. So in every programming languages, we use collections. So it's an important part of a programming language. And before Java 9, working with collections in Java were a bit cumbersome and verbose. I think starting from Java 9 or 11, you can use also helper functions, and it makes much easier to work with them. But before that, it was harder to work with collections. But in Kotlin, from the very first version, working with collections is much simpler. So basically, you create collections by using helper functions. Like here, you use list of to create a list. And you don't have to give the type. So because Kotlin using type inference, it will know that this is a list of strings. If you change the types, it will figure out what is the type what it needs to use here. You can use mathematical operators to work with lists. So in this example, we can add value 4 to this list, or we can remove the value 2 from the list. And you can access list items like you would access an array in Java. So it's an array-like accessing. But normally you get here an error. You would get here an error because collections are also immutable in Kotlin. And this means that you cannot change the items. So in Java, if you use the default collections, even if you assign it to a final variable, you might think that that's immutable, but that's not true, because you can access the item by reference. So you say that get the item on the index, let's say index 2, and change its value, and you can. But in Kotlin, you cannot. Of course, in Java, there are some ways how you can do the same behavior. And in Kotlin, you can also use mutable lists, mainly using helpers with mutable prefix, so like mutable list of. But by default, Kotlin uses immutable collections, and this is also important because in Java you work on the same reference, and sometimes it can cause some hard to spot problems. So Kotlin tries to force you every time to work on a new collection. So when we add a new value to this list, basically we will get a new variable what holds a totally new list. Okay. Kotlin also has sets, which is basically the same as in Java. So the order of the items are not guaranteed, and you cannot have duplicate values. You can create it with similar helper functions, so it's set off, and it has some operators which are more familiar to people coming from mathematical backgrounds. So union will merge two sets. Intersect, basically it will give back the common items, and subtract will remove any of these items from the original set. Maps, basically just like in Java, you can create the collections of key value pairs. Of course, here again we can use a helper function for this, and it's very has a very short syntax. You just add entries like a key mapped to a value, and you can also use here arithmetic operators to work with them. So you can add a new map to it. Of course, the same key will override the value, and you can remove entries by removing the key. And you can see here that if you would like to do something similar in Java 8 or before, you have to write much more. So basically, you have to create the function, the variable, and you can add values one by one, key value pairs one by one. Okay, so we already know about collections, and most of the time we work with collections. We iterate over them and then make some transformations or just print out their values. In Kotlin, we also have a for loop. But in Java and in many programming languages, by default, you use a for loop this way. So we have an array here. It's having values 1, 2, 3, 4, and 5. And you have to make an iteration which goes through the items, and you will get the index of the item, and you need to read the value from the given index. So you have to reference back to the index. You must be aware of the index when of the item when you work with the item. By default, Kotlin uses a different approach. This is a for each like syntax. So by default, it gives you the values. You don't have to know about the index. Of course, you can if you want. So there are ways to find the index as well. But by default, it will give you back the value of the item one by one. So you say with this in keyword, put into this variable the value of every item, and you can print it out. If you would work with map, you can use the key and the value in the same iteration. So you don't have to access entries. You don't have to get the entries. You will get the key and the value separately. And of course, in Kotlin we also have while and do while. It's pretty same as in Java, so I will not talk about this right now. I mentioned ranges before. Basically, it's a short way to write down range of values. So basically, this is how we describe a range. So this is 1 to 5, and this means it will create a collection holding sequential incrementing values. So this collection will have values 1, 2, 3, 4, and 5, and it is easy to pass into a for each loop. So this is how you can write a for loop in Kotlin with 5 iterations. Ranges can be used also in conditions, so you can check if a value is within a range. In Java, you would write it like this with 2 conditions, like 3 is greater than 1 and 3 is less than 5. Or maybe you can create a collection with values and check if 3 is within the collection. And ranges also gives you some flexibility, so you can also create a reverse range with the down to keyword. So this will create a range having values 5, 4, 3, 2, and 1, and it lets you skip some values. Like here we have step 2, and this will create a range having every second value, so 1, 3, and 5. Okay, so as I said before, most of the time we use with collections and we do some transformations on it. Java also has a good way to use this. Starting from Java 8, they started to introduce streams, and it helps you a lot in collection transformations. Of course, we have this in Kotlin as well. In this example, you can see that we create a range from 1 to 10, and we will filter out the odd values. This is a lambda function in Kotlin. Basically, it says every item, if it's divisible by 2 and has a remainder, so that's an odd item, and it can move further for another transformation operation. This is a map. We add 1 to each value. So we will have here 2, 4, 6, 8, and 10. And we would like to take the last 3 items and make a total from it. So add them together. If we compare it with Java code, for the first you can see that this is how we write a lambda function in Java. We have an input variable, and we will use it in the function. This is the expression, what stands for the function. In Kotlin, if we have a single input variable, we can just simply write it. So we don't have to use this arrow referencing. You can just refer it with it keyword. And another big difference that in Java we have to use stream to start to work with collections. Okay, not in this example, because this is a built-in helper class to create a stream, but usually we need to add a stream after the collection, and at the end of the operations we need a terminal operation like collect it to a list or something. In Kotlin we have these transformation operations on every collections by default, so you don't have to call anything special just to start to use them. And this is because these operations will return a new collection. So because of immutability, they will work on whole collections. When you use small sets of collections, this is very useful. If you would like to use large collections, you would use something similar to Java streams, a lazy stream. So you have the chance to work with big collections as well. but by default, this is what Kotlin gives you. And another difference is that Kotlin gives you much more operations. So it has a lot of handy and convenient conventions. Yeah, and especially when you work with maps and groupings, I think it's much easier to work with Kotlin in this scenario. And finally, we have classes. Of course, with classes we can hold data and state, and this is how you would write a class in Java. So we have a person class here. It has a name property, and because it's private, we need a getter to get the value. And if you would like to write an immutable class, you need to assign value on construction time. So you need constructors, and if you also would like to handle default values, you have to handle it even in a default so either in the default constructor, or if you use a custom constructor with an argument, you should check if it has a null. So it has a couple of lines to write. So you need to write some line of code. Later you will create a new instance from this class. It will have a default value, of course, and you can call the getter to get the value of the property. And of course you can have equals and hash code methods or toString methods, so it's a lot of code. In Kotlin you can rewrite this in a single line. So this is how we create a person class, and we define a property, a name property. Of course, it is immutable. We give a type to it, and we also give a default value. And this will generate a similar Java bytecode, what we've seen before in the Java code. So you will have getters. If you use immutable variable, you will have setters. You get constructors, equals hash code methods, toString methods, and because you can also use here default values and named arguments. Basically, you can create objects without using any builders. So if you work with bigger classes with a lot of properties, probably you would use a builder because it makes it much easier to build up to make a class. But it comes out of the box with Kotlin. And to avoid a lot of boilerplate codes in Java, we use Project Lombok. It also can generate you this stuff like getter, setters, and constructors. But when you use Kotlin, you don't need to, because everything is out of the box with the language. And this is how you create an instance. In Kotlin, you don't have to specify the new keyword. You just simply call the constructor, and you can give the arguments. Here we use the default value and call the property. And in the Java bytecode, it will call a getter. So you don't have to care about getters. Kotlin will do this for you. Yeah, and of course you have the chance to write custom constructors, which has some logic or initializers as well. Okay, so you can see that Kotlin tries to help us a lot to not write boilerplate codes and to write safe code. This is just a basic introduction. So if you would read more about Kotlin, you will see that in advanced topics, Kotlin can help you even more. But I think this is enough to start work with Kotlin. So we will have here a short demo. And later you can find the demo and the presentation on this link on my GitHub account. And if you would like to know more about Kotlin, I recommend you to read the official documentations. It is very easy to understand, and it has a lot of interactive shares on the web page, so you don't have to install anything just to start try out Kotlin codes. Or if you would like rather read a book, I recommend you Kotlin in Action. Okay, so we will have here a short, a tiny application. This is basically a library application, so we will have books and libraries, and there will be a small class which makes some statistics from the libraries. And as I said before, Kotlin is fully interoperable with Java, so you can have Java and Kotlin files in the same project, and you can call the classes from Java and Kotlin in both directions. So it's pretty easy to use it. And Kotlin is also flexible regarding to file usages. So this is why we have less files here, because it gives you more freedom. And we start to write our classes. You can have more public classes in one file. And because it's short to write a class, especially if they hold only data, you can put them in a single file, especially when they belong to each other for some reason. So you can see we have here an enum for the department. It works the same way as in Java. We have a class for a book. It has a title, an author, year when it was published, pages. So how many pages does it have, and the ISBN code. What can be null? So this is a question mark. What means that it can be null, and the default value is null. So if I don't give it, it will be null by default. And this is a class for the library. We have a name for the library. It can have a website. So basically, this is an optional variable. Established, what means is the year of establishment, and a map holding books by department. So the key is the department, and it holds a list of books, and by default it is empty. If you would compare it to Java version, of course it has a lot of code. Okay, most of it can be generated, but anyway, it's still there, and you have to work with it. And this is the library. And I created some classes to create some test data. And you can see this is how I create the book. Basically, I can call the argument by its name, and I always know which argument stands for what. And you can spot here that we use these fancy names for variables. So when you use backticks, you can use any characters in variables and functions. This is recommended only in tests, but it's good to know. It can make your code much easier to read. And sorry, this is how we create a library. And you can see that when I create a library, the same step I can create the map with the books. I think it's pretty easy to read. And it's important to note here that we create the map in the same construction phase. So when we create the library, because if you compare it with the Java version, sorry, this is it. Then we can see that mostly in Java 8 and before, we cannot do it in one step. So we need to create a map before, and we can fill up with key value pairs one by one later. So I created here a private function to make it more readable. But basically, it's multiple steps. And this is the class which will create the reports for us. I created here a couple of methods. So let's create a method that will count the number of books in a given library, and of course it will return an integer, the number of books. And usually I would start to write something like this, that here's the library, I get the books by department, and I get the values of it. So there will be so there will be a collection of lists of books. So the values from the maps are aggregated into a single collection. And to count the books, I would use a variable here and iterate over the list of books and add the size of each collection to it. And this is perfectly fine. It works in Kotlin, but as you can see that we use here a mutable variable because basically we have to increment the counter in every iteration, and this is not nice. So I would rather rewrite this using these collection transformations, and I can return the value as an immutable variable. So I get the values as well, and I can use map, which will basically map every item in the aggregated list to a new value. And here I get the size of the collection within, and calling the sum method will add the values. And you can see that because I can write everything in a single expression, I can basically, this is a one-liner. I just split it into multiple lines, but basically this is a one-liner function. Okay, let's write another function what returns. Actually, I run the code so you can see the result. So it makes it easier to understand, I guess. Okay, yeah, and this will be the result that the total number of books in Library of Alexandria is 6. Okay, write another function which counts the total pages by department. So we have here a library, and here I get again the books by department, and I get the entries because as you see in the result that I would like to count the number of pages in every department separately. So I will map the entries one by one to something else. And of course I use map again. These are the key value pairs, and the key stays the same, and the value will be mapped. It would be similar what we did before, but instead of it.size, we use it.pages. But Kotlin, as I said, gives you a lot of handy functions. Gives you this sum by, what basically means do a mapping to it.pages and also add the values. So you can write this stuff here even shorter. And because these are just collections of entries, you have to convert it back to a map. So you have to use to map. And a third function which will return the total pages in the oldest library. So we give a list of libraries here. And first we need to filter the libraries. So find the oldest library, which means it has the lowest number here in the established property. So we can use this min by function for this. And we will get, as a result, a single library. And again, we get the values. And because we will get a list of lists, basically, So I write here what this flatten does. So we will have a list of book, but we need just a single number. We have to count the pages from every department and add them together. So it would be better to have just a single list. It makes our life much easier. So this flatten basically means this. It will aggregate this list of lists into a single list. So this is flatten. Okay, and after that I can call it again the sum by method, and it will say that the oldest library is Alexandria. I mean, the Library of Alexandria, and it has nearly 6,000 pages. Okay, in my example, of course. And this is how I create my main method. I create an instance of this library statistics, and I can call it directly into the string if I want, and it's still pretty readable, I think. Here in the third method, I create the list before, and I call the total pages in oldest library method. And if you compare it with the Java equivalent, of course I use here Java streams, but I think it's you can see that it's much verbose. You can read and it's understandable, but it's more complicated. So I think for a beginner, the Kotlin equivalent is easier to understand. And this is the main application. I'm not going over it again because I'm sure that you know what is happening here, and you will find the demo on my GitHub as well. But you can see that it's a bit more verbose. Okay, so that's all. I don't know if you have any questions. I stop share my screen, I guess.
Hello guys, if you have some question, I have turned on the question answer session. You can ask in the chat or maybe in question answer tab. Just waiting for your questions.
Thanks. Actually, until you write some questions, I just show you something what might miss your attention, but it's an interesting thing. Here I used this 2 exclamation mark. It's just a good information that. So I said that Kotlin by default uses nullable types, but some operators might return null values. Like this says that it can return a nullable library, and if I does not specify this on every further operation, it will complain that this can have a null value, and so basically this is a compile time error, and I have to handle it. I can handle it with question mark, what means that if this will be null, then don't go further, just return a null or do nothing. But here I have to continue this question marking stuff. But if I say that, okay, I'm aware of what I'm doing with these 2 exclamation mark, it's a bang bang operator. I say that I know that this will never be null, so this is my responsibility. And if it will be null, then I can get a null pointer exception. Okay, that's my fault. So basically, compiler here lets you do whatever you want.
Okay, I have a question. Like in the when statement, you have shared that -1, -2 lambda expression or goes to sign then -1. What does that do? Like, in the when operation?
In the when expression. Sorry, where is this? Yeah, here. And what was the question?
Okay, just open the when operation slide, the slide number, slide number 13. Yeah, the third line, like -1, comma -2 goes to -1. What does it mean? Like?
Yeah, so basically this means that either the number is -1, either it is -2. Just return -1.
Okay. Okay.
So it's basically it's an or condition here.
Got it. Okay, we have another question in the chat from Yasin Gaur. He's asking, he's working on Android for his thesis, and should he convert it to Kotlin from Java or not?
So you are using Java in Android, and you would like to use Kotlin? That's the question. Yeah. Well, it depends. What are your needs? So the industry started to use by default Kotlin for Android development. So if a project starts from zero, they probably use Kotlin because it's much easier to work with. But many old projects are still written in Java, and maybe they started to rewrite it to Kotlin, but it makes time. So a lot of projects are still runs on Android in Java. But so if you have a short schedule, probably you know Java better, and it's easier to you to work with Java. But if you can afford to learn Kotlin, and I think Kotlin has a really small, short learning curve. So if you can afford to spend just a couple of weeks to learn Kotlin, I recommend you to start with Kotlin. So I'm not an Android developer. I don't know how hard it is to work with Kotlin in Android, but basically it was by JetBrains, it was made for Android development from the first time, and later they started to use server side and other platforms. So it's a good fit for Android development. So if you can afford to learn it, I recommend it.
Okay, we have another question. Kotlin or Java, like which one is faster and which one is safer? But both have same.
So Kotlin is safer because it gives you more safety. As you could see, it warns you. It gives you a lot of compile time error, and helps you to act faster. And in advanced topics, it has even more powerful things, which helps you to write safer code. Faster, like performance, it's a interesting question because, of course, it has some overhead to use Kotlin, but it's not that big. I would say, as I read some statistics, it's at most 10%. So it helps you write a code faster, but the performance loss is not that big as you would. So it's hard to realize. But I think it's a big benefit to help you work faster because in the industry, we can say that the human resource is much more expensive than the compute resource. So if it works slower, we give it more resource, we pay a little bit more, but to hire 2 or 3 more people, it might be more expensive.
Okay, thank you for your answer. We have another question. When Kotlin is compiled, will it compile in Java bytecode or something else?
Yes, it's basically compiled to Java bytecode, and you can specify to which Java bytecode. So it supports, I think, 6 as well, but by default we use Java 8 version, and now it supports Java 11 as well. So basically you can write a Kotlin application, and if you can upgrade your Java virtual machine, you just simply have to say that the target version is different now, and you recompile your project and it will run again.
Okay. Yes. Okay, then I don't think so. There's some other questions. So thank you so much for coming.
Okay.
It was a great session. Thank you so much.
You're welcome, and I hope that you will start to learn Kotlin, because I think it's really it's a really cool language.
Yeah, it is.
Okay, so it was a pleasure to be here, and have a nice day. Guys.
Okay, guys. So this is the end of our session, and I'll share the resources soon with you by email and your certifications. Thank you so much. Hope to see you again in some other session. Bye bye.
Thank you. Bye.